Linux is always running many processes at the same time. A process is simply a running program using system resources like CPU, memory, storage, or network access. Some examples of processes: terminal sessions, web browsers, GUI desktop services, databases, security tools, and background system services. As a Linux user, and especially in cybersecurity, you need to know how to view running processes, find specific processes, see what uses the most resources, change priority levels, stop frozen or unwanted processes, run jobs in the background, and schedule tasks automatically. To view a basic process list, type PS. This shows PID, which is process ID, TTY, the terminal it belongs to, time, CPU time used, and CMD, program name. This only shows processes running in your current terminal. To view all processes, type PS aux. This shows every running process for every user. The important columns: user, who started it, PID, process ID, CPU usage, memory usage, and command, the program name. This is useful when checking what the whole system is doing. To find a specific process, type ps aux, use the pipe command, grep, and the process name. Here we will use msf console. What this does: ps aux lists all processes, the pipe command pipes the output, grep msf console searches for that name. This is very useful for Metasploit, Apache, SSH, Python scripts, and malware analysis. For real-time resource monitoring, use top. This shows live running processes sorted by resource usage. You can monitor CPU usage, RAM usage, running tasks, and load average. Top updates every few seconds automatically. The controls inside top: Q to quit, H or question mark for help, K for kill process, and R for renice process. Linux decides which process gets CPU time. You can influence this using nice, start with priority, or renice, change running process priority. So the nice values: -20 equals highest priority, 0 equals default, and 19 equals lowest priority. Lower number equals more CPU priority. To start a process with higher priority, type sudo nice, use the end switch, -10 /bin / the process name. This starts the program with higher priority. To start a process with lower priority, type sudo nice, use the end switch, 10 /bin / the process name. This runs process more politely, giving others more CPU time. To change priority of a running process, use sudo renice 19 6996. This changes PID 6996 to lower priority. This PID doesn't exist here. To change priority in top, type top, then press R. Enter PID and the nice value. So killing processes. Sometimes programs freeze, hang, or use too many resources. Use kill. So normal kill, you would type kill 6996. This politely asks program to close. To force kill, type sudo kill -9 6996 or whatever PID you're using. This immediately stops process. Use when frozen. To restart process signal, you would type sudo kill -1 and the process ID. This often reloads config or restarts process. So here's some common kill signals. So you can kill by name instead of PID. You would type sudo killall -9 and the process name. What this does, it kills all processes named, in this case, zombie process. Useful if PID is unknown. To kill inside top, run top, then press K and enter the PID. To run processes in background, normally terminal waits until command finishes. So let's type mousepad, new script. Terminal becomes busy. To start directly in the background, use sudo mousepad, new script, and the and symbol. What and does, this runs program in background and gives terminal back immediately. Useful for editors, scanners, scripts, and downloads. To move existing process to the background, use BG or job control after pausing. To bring process back to foreground, use FG. This returns latest background job. Some systems may also use FG %1 for job number 1. Now we're going to schedule some tasks, useful for backups, scans, scripts, and updates. Linux uses run once later, and cron, repeat jobs. Install sudo apt install . Now we're going to schedule a job. Type sudo at 7:20 AM, then type /root /my scanning script. Finish with Control D. Here's some other time examples. Run tomorrow, so at tomorrow. Run in 20 minutes, at now plus 20 minutes. Run in 10 hours, at now plus 10 hours. Run in 5 days, at now plus 5 days. And run on date, at 7:20 PM, June. So why this matters? A hacker or pen tester may need to find antivirus processes, stop firewall services, run scanners quietly in background, prioritize cracking tools, schedule recon scripts, or monitor system load during attacks. Process management is a core Linux skill. You should now know how to view processes, search processes, monitor usage, change priority, kill bad processes, background tasks, and schedule jobs. Master this and you control what your system is doing. I hope you enjoyed this video. I'm CyberEd and I will see you in the next one. Peace.